Okay, ladies and gentlemen, here we are for another lecture. Uh, I will make a lecture just for the bell work portion of this, and then make another one for just the notes portion of this. So we'll work the bell work here first. So this first question, we're dissolving 5 grams of sodium hydroxide in water to make a 500 milliliter solution. They want to know what the pH of the solution is. So remember, in order to calculate pH, we got to know the concentration of H plus, or we need to know pOH, which would require us to know the concentration of OH minus in solution. Okay, so we can use our pH square there. And just keep in mind the relationship between H plus times concentration of OH minus is always equal to 1 times 10 to the minus 14, which is also known as Kw. Okay, so as we move forward, first thing we gotta do is we gotta figure out what the concentration of hydroxide ions are in solution. So we need to do a little mole conversion here. So 5 grams of sodium hydroxide. Okay, we know in 1 mole of sodium hydroxide there is 40 grams. All right, so that gives us 0.125 moles sodium hydroxide. All right, and ultimately, because it's a strong base and it's a 1-to-1 ratio, we know that there's 0.125 moles of hydroxide floating around in solution. And if we divide that by the volume, 25 liters, we got the concentration of OH, which would be 0.25 molar for OH minus. All right, so then we can figure out what the pOH is. That's the way I like to go. So pOH would be equal to negative the log of 0.25, which is 0.602. And then we just define the pH. That's equal to 14 minus 0.602, which is equal to 13.398. Okay, so there we go. We got that one. And then they're asking, all right, well, how much water would we need to add to make the pH of solution 13? So if the pH is equal to 13, whoops, then we know that the pOH has to be equal to 1. Okay, well, in order for us to figure out what the concentration of OH minus is at that point, that means that we need to take 10 and raise it to the negative pOH, and that will be equal to 0.10 molar. Okay, we need the concentration of that solution to be 0.10 molar. So essentially what we have right now is we have a 0.25 molar solution, and it's 500 milliliters. Okay, and we're adding water here. So guess what equation I'm using here? M1V1 equals M2V2, the dilution formula, because we're diluting, we're adding more water here. And our new volume, our new molarity has got to be 0.10 molar. So the new volume of that solution is what we can solve for. Okay, so 0.25 times 0.5 divided by 0.1. So the new volume of our solution is 1.25 liters. That's the new total volume. Key component there is total. So we started out with 0.5 liters, and now we got 1.25 liters. So we ended up adding 0.75 liters of water. And so how did I get that? Well, 1.25 minus our original volume. There you go, 0.75 liters. So there's the bell work question for today. And we're going to be doing a lot of strong titrations today. So it's going to be fun stuff.